My name is Parashuram, or Ram for short, and I work at Facebook on the React Native team as a software engineer. I started my software engineering career as a web hobbyist, like many of you here. This was way back, and honestly, I'm not as old as I look, but back in the day, my first exposure to web was basically tinkering with pages dedicated to games forums. My first web browser was actually a Netscape 1.0 or something on a Windows 95, for those of you who know what Windows and Windows 95 is. In fact, I didn't own a computer myself, so I went to this uncle of mine and asked him if I could help him get his presence online. My sale to him was, hey, if you go online, you'll become rich instantly. Now, I know it sounds like a scam that a lot of people hear, but that was just my way of trying to see if I can get some more extra computer time. So he was OK with it, and he effectively wanted, all he said was, hey, that sounds fine. Can you just build me a page where the name of my shop is on the center of the screen? Now, back then, I was young and stupid, and I didn't realize that this was actually a trap. Because as a web developer, over the years, the one thing I've learned is vertically aligning text on a web page is hard. Well, he wanted me to build that. I started working on it. And most of the things that I was doing was basically picking up, trying to understand the differences between an LI and a UL, or a div and a span. I was copy-pasting code from all over the place, trying to understand what was happening, trying to do the DOM manipulation myself. And I finally came up with a website that sort of looked OK. This was the version of the website, or how it looked back then. There was only one product-market fit problem. The issue was the store was in a rural part of India, and this was a part where not a lot of people had seen a computer before, and there was no internet. So effectively, I ended up deploying this on a local, on the front desk, and whenever someone came into the shop, I actually called them over to have a look at my site. My perspective of web development since then has changed a lot. The internet definitely has gotten much faster, and we no longer think of web development in terms of spans or LIs or divs. We actually take a step back and think of the user experience in a much more holistic fashion. In fact, we now talk about things like information organization and information hierarchy, and thanks to frameworks like React and Angular, we don't have to worry about those pesky DOM manipulations. We just pick up the things that we want to display, and then declaratively say that this is what we want on the screen. React.js, the web library, is gracious enough to obey our commands, and it sends all the information that we want and takes care of and ensures that all of this content is actually displayed on the screen pretty well. Any updates that we want to do, we don't have to worry about it. We just declaratively tell React that we want to add a node. React does its own magic of reconciliation, figures out that whether we need a DOM operation or not. And then if we do need a DOM operation, it'll just say document.createElement and do the DOM operations for itself. The other thing to note is React sort of holds a handle to the DOM node that it created. And once we want to change a style or change an attribute, we just tell React what to do, and React would take care of it for us. This is pretty good, and I think this way of programming gives us this advantage where we don't think about the nitty-gritty details, but are able to think at a higher level of abstraction. Now, the interesting thing to note is the node that we get back in React, it actually can call methods on it directly. For example, in this case, what I can do is, I can call methods directly on the node, and I don't have to worry about, like, hey, it's just a DOM node. I don't worry if the browser supplies it to me or if it's a JavaScript object. The other good thing about React is the fact that it's learn once, write everywhere. And thanks to a framework like React Native, I can now convert or use all of my knowledge from React and try to build mobile applications. Now, I want to pause here and see how many people here have a React Native application that's in the App Store. OK. And how many of you here are currently working on a React Native application that you want to put on the App Store? It's sort of dark here, and because we are on the camera, I'm just going to say, wow, that's amazing. Everybody raised their hands. I didn't realize React Native was that popular. Well, jokes apart, I do understand that a lot of you here are web developers, And bear with me, there is content here for web developers too. I mean, React Native and React aren't that different. Most of the knowledge that you learn with React, the whole components, lifecycle, all of that can apply. There are some subtle differences that we need to be aware of. For example, there is this big gap where in the React Native world, we are actually bringing two giant worlds together. We are bringing the JavaScript realm and the Android or the iOS realm together. Now, what that means is because React Native lets you create native user interfaces or native elements, you really cannot have access to the node directly. So you see that pink wiggly line there? That cannot really happen because this is a completely different realm, right? Like the node that you get is from the Android world. So that can't be there, which also means you can't call methods on those nodes directly. And that's one subtle difference between React and React Native. And to address this problem, we will have to ensure that there is another way to communicate between these two worlds. In the React Native world, we call it the React Native bridge. The best way to think about the bridge is a simple mechanism to pass messages over from the JavaScript world to the native world and back. I think the best way to explain it is whenever React does its reconciliation, it comes up with a bunch of commands. Say, for example, create a node or create a view, etc. And what React Native does is it parcels all of this together in a JSON array, serializes it as a string, and simply passes it over. Now, this is probably the simplest explanation of what the bridge does, but it accomplishes our main use case of communicating between these two worlds. The other big gap in this system is we haven't really spoken about layout. Now, on the web, if you ask web developers about layout, the answer is going to be Flexbox, right? The Android UI doesn't really understand Flexbox. Android has its own layout system, and because of that, because we want to ensure that there's consistency in the way we write our React Native applications, we might have to implement our own layout system. React Native does exactly that, and because we cannot really use Flexbox out of the box, we implement our own version of Flexbox in a library called Yoga. The best way of thinking about Yoga is this library to which the inputs are Flexbox style inputs, and the output of this library is relative positions of where each of the elements should be structured. Once the layout has been done, React Native effectively sends this over to the UI layer, and this is when all of the entire operation set is flushed to the UI, and the UI draws all of this. What you see on the screen can be considered a canonical diagram of how React Native works. Effectively, React Native has three main threads. The main UI thread, this is the place where all of your scrolling and all of your rendering, all of your view rendering happens at the platform level. There's the layout thread, which is sort of a background thread where most of the layout happens. And then there's the JavaScript thread. This is where all of your React, business logic, all of your JavaScript works. The fact that there are these three threads is actually pretty amazing. Because you have these three threads, most of the heavy operations happen in the JavaScript side. All the reconciliation, all of your business logic happens on the JavaScript side. And your Android thread is very, very empty, and it pretty much can respond to all of your requests immediately. So to summarize, the other thing I also wanted to do before going forward is rename them. So rather than just calling it Android all the while, let's just call it Platform UI, and then let's call the middle one a shadow tree. The reason why it's called a shadow tree and not layout is because, one, calling it a shadow tree is much more cooler than calling it layout. But on a more technical sense, it's just a copy of your React reconciliation tree. So the tree that React constructs in the JavaScript side, the shadow tree is basically a copy of it. So what I'm trying to say is the UI updates, the JavaScript and layout operations happen in three different threads, and the communication between these is asynchronous. This is also pretty amazing for performance. I mean, over the last 2 days, given all the excitement about hooks and about how React can be concurrent and asynchronous, this is pretty good. In fact, I'm so excited I'm as excited as this. Looks like somebody was having a lot of fun yesterday at the word games, and they forgot to remove the to-do. But you know what? I guess I'd use this as an opportunity to show you how important not blocking the UI thread is. What I would do is, if I was single-threaded, I'd quickly go in, open up Google, try to search for the images and replace it. You are all staring at the screen, trying to figure out what's going on. I'm a little bit nervous. I might try to pretend like I'm drinking water, but it's all happening on its own. But effectively, if you notice, my main thread of conversation has not been interrupted. I'm like that loading indicator where I'm effectively trying to talk to you and conversing with you at 60 words per minute. So your UI thread hasn't been interrupted. This is like a background operation that happens in the background. So OK, fine. That was a very bad that was very badly enacted React Native architecture. But I think the point is React Native is asynchronous, and this is super useful. Now, I was so intrigued by this idea that approximately 2 years ago, I thought everything should be asynchronous, everything should be multi-threaded. I tried this project where I implemented React on a web worker. I mean, that's the only thing you get that you can get as close to in terms of threading, right? So I implemented React on web workers, and I thought that was the coolest idea. Now, as software engineers, over the years, we have this thing where one day we wake up, look at the code, and say, what the hell is going on? Only to realize that it was our former self who has written the exact same code, right? Well, that's exactly what happened. So when I wrote React, when I wrote the whole worker thing for web worker thing for React, I thought that was the best idea. But as I started using it, I actually found flaws in it. One of the biggest problems in that was the fact that because it is asynchronous, I could not really respond to like events, or I could not cancel events. So that's a problem. The second issue is the fact that all of this is asynchronous does not give you that quick look, the quick response that you would need, all the things that James was talking in his previous talk. Now, interestingly, this is the same problem that React Native also suffers with. So in case of React Native, let's say you have a really, really long list with a really, really large number of items, and you try to scroll really, really fast. You might end up in the situation where you'd see white patches before the actual rendering happens. This is not a very common case, but this edge case does happen. The reason why this happens is because when you have an on-scroll, the on-scroll event is sent to the JavaScript thread. Now, the JavaScript thread is not synchronous, so you would basically respond back in an asynchronous manner to the shadow tree where the layout happens, and then the next response happens to the main thread. And by the time this entire jump and hop happens, the scroll has completed. The scroll needs to be synchronous. As soon as you scroll, you need to know what happens on the main thread, right? With the current architecture of React Native, you may not be able to do that. This is a problem, and interestingly, this is one problem that the web has solved pretty well. I mean, you don't see this commonly on the web. On the web, you can cancel your scroll events. Your animations can actually be imperative. So let's try to look at this and compare this to what the web does. So the top is React Native. At the bottom, I'm going to show you what I showed in terms of the web. So on the web, what you basically had was React sending out commands, creating a node, and then the browser taking care of drawing all of the things. One way to look at it was the layout engine that you have. So that's the difference. That yellow line that you see differentiates JavaScript from the browser land. But if you start probing into the browser in a little more detail, what you would notice is the layout engine is actually a part of the browser. Any control that the browser draws, for example, we want to draw, say, a checkbox, the browser draws that using the native operating system. So if you're on Windows, it actually uses the Windows operating system and uses the rendering engine to draw that system UI. The other thing to notice is when you say document.createElement, the object that you get back is an HTML input element. That HTML input element is not a JavaScript object. It's not like somebody created that JavaScript object. It's an object that the browser has created for you, right? It has a bunch of properties, but it also has an internal reference to the checkbox that you drew. Now, with this knowledge, let's try to compare and see how does the React Native world look like. So in the React Native world, the UI is still native UI. Like the whole point of React Native is that all the UI elements are native elements. You don't use just a web view. You don't pretend like it's native. It's actually really native. So that's what it is. What you really want is you want this world where you can get an element similar to the HTML input element, which basically means you will not want to play around with like serializing JSON and sending it asynchronously. The bridge probably is not the best choice for our use case. In fact, what we want is something that's a little bit better than the bridge. What we really want is, so first let's burn the bridge, because the bridge isn't helping us. The API that we want on the React Native side is also similar to what the browser already exposes. We want to be able to create a DOM node using a function call, and then use that DOM node and set attributes on it. I'd like to introduce you to the new interface that's a way for communicating between JavaScript and the native land. Very creatively, we call it the JavaScript interface, or JSI. And this is basically a simple way for JavaScript to talk to Objective-C or Java. What you get back is a host object, very similar to the HTML input element. And then you can call functions, and you can access methods and properties on it. So unlike the bridge, there is no serialization. You don't have to worry about sending stuff over the bridge, nothing of that sort. This is actually much more similar to the browser than the whole bridge architecture. In fact, the JavaScript interface is so important that this is the basis on which we build our next generation of React Native interactions, like the next generation of React Native view managers and the next generation of React Native native modules. So how does this work with native modules? The thing to note is, let's say you have the 3 threads that we have been talking about. As soon as React Native starts up, you have this thing where you start the run application. That starts up in a UI thread, and in this diagram, I'm using the green box to denote the UI thread. It schedules some work on the background thread being represented by the blue boxes, and any sort of scheduling being represented by the dashed arrows. So here, your work is scheduled on the background thread. And then on the background thread, React does its reconciliation, figures out that it has to add like layout nodes and stuff. And then all of this is eventually scheduled back on the main thread. So this is how React Native works today. And this is the only way React Native can work today. But what we want is all of this asynchronous thing may be OK for most cases. But as I said, there are some edge cases where we do not want it to be as asynchronous. So let's say you have a network call, for example. Now, you've already spent, say, 1 second waiting for the network call. If you wait for another 1 millisecond for all of this asynchronous stuff to happen, that's perfectly fine. However, if you have a synchronous operation like a scroll event, or you have a synchronous operation like an animation, in those cases, you want it to finish as fast as possible. So rather than scheduling the responses to those events in a background thread, you should just as well run them on the UI thread. And as James said, it's OK, go on, block the UI thread, as long as you're inside the budget. Now, once the UI thread finishes its job and the stuff is drawn on the screen, React can then start resuming its earlier work, which the network started, and then flush that operations also. Now, what this diagram shows you is pretty much how the new version of React's UI manager will work. As James was saying, we call it Fabric. I mean, Fabric is not really the official name. It's just the term that we use internally to refer to the new architecture of React's UI management. This is how it will work. And in this case, in this diagram, you see how we can run UI operations both synchronously and asynchronously so that it's not blocking. The other typical use case of React Native would be a case where you have, say, a completely native application, and you want to embed small parts of React Native in the screen. Now, today what's going to happen is you'd add the React Native view, and then you'd start scheduling all of the React Native work. Because all of this happens asynchronously, this is just going to happen in a background thread. But on the main thread, you would have already added your view. When we add the view, we do not know what the height or the width of that view is. So at this point, we have nothing rendered in React. So it'll just get added with the default height and width. The default height in most cases is 0. So it'll just get added with the default height. Then React will eventually finish. And the background thread will be able to tell us what the size of that React Native container is going to be. And then eventually, the UI thread will update to tell us that, hey, this is the eventual size. Now, this isn't this isn't a good user experience. If you notice, you'll have a jank where something appears and then suddenly it expands. This isn't good. On the native world, you don't typically expect this. This is actually worse for animations. And with the new world, if all of this was not asynchronous, but if all of this was happening on one thread, and you could just block till the whole operation completes, this would be much more smoother. So this is how the new UI manager for React Native would look like. And this is all powered by the new JSI or the JavaScript interface. If you were to compare this to what happens on the browser, when you say document.createElement, the new UI manager would be exactly the same. Apart from doing UI stuff on the browser, there's also a lot of places or a lot of use cases where we access device capabilities, let's say camera or Bluetooth. The browser does have a limited set of those capabilities, and if you're writing a mobile app, you'd probably have many more use cases where you want to access non-UI device-specific capabilities. So let's take the example of, say, accessing the camera. So today what's going to happen is in the browser, when you say navigator.getUserMedia, you're typically trying to get a picture. If you open your browser console and try to figure out what this getUserMedia is, what you would see is the actual contents of getUserMedia. That's a native function, or that's a native code. That is not a JavaScript code that anybody has implemented. It's something that the browser gives you. So in a way, the navigator object has a ton of methods, and a bunch of those methods actually call into browser internals. They probably call into methods that were implemented in C++ or whatever platform they were written in. Using JSI, we can apply this exact same mechanism for all of the native modules too. What you would typically be able to do is you would say get native module of camera, and then when you say get pictures, what you would get is rather than giving you a JavaScript function, this React Native could give you a C++ function. And this C++ function internally could call the actual Java or iOS implementation of how to take a picture. So this way, you don't have to send anything through the bridge. There is no serialization. There is no deserialization. You are effectively just directly calling the APIs. The reason why this is important is because of this use case. So in this use case, let's say you want to take a picture, and then you want to upload it using an upload plugin. And to that upload plugin, you will pass this picture in, right? So this is a typical use case. If you have to do this today, this would run on 2 different worlds. And the way it would work is you'd call the getPicture method. This will get the picture. And once you take the picture, it's available in JavaScript. And then you'll pass the picture back to the native land. Now, because you're going to be using the current bridge, you can't just cross objects over, so you'll have to do the serialization and deserialization part of it. Now, this is expensive and quite unnecessary because all you're doing with the picture is just holding a reference to it in JavaScript. In the new world, what you will be able to do is rather than passing the entire object over, you just hold a reference to that object. Once you have the reference to that object, you just pass that back into the upload function. And using JSI, that upload function will just do the upload. And because this is an opaque object, if picture has methods on it, say if you want to say set alpha or something, you actually can call those methods in JavaScript. So this is what the new generation of native modules would look like. The term that we have been using internally is turbo modules, but effectively this is how native modules is going to look like. The API would be, you'd be able to get a native module, which will give you a JSI host object. This host object is going to have methods and functions which you can invoke. And the return value from functions could themselves be host objects. So this will pretty much be like an RPC call between JavaScript and the native realm. No presentation is complete without a block diagram, so I'm going to put in the obligatory block diagram for React Native. This is typically the architecture of React Native. You have the main React instance, which is all of the Java or the Objective-C code that you write. You have the JavaScript virtual machine on top of it, and then React code and your product code pretty much interact with this JavaScript virtual machine. Whenever you want to draw something on the screen, you would be using View Manager. So for example, if you want to draw a scroll view, you'd be using a Scroll View Manager. And if you want to invoke device capabilities, you'd be using what's called a native module. React Native is also extensible in a sense that you can implement your own view managers or your own native modules. One of the things you notice here is React Native, the core of React Native comes bundled with a ton of view managers and native modules that you may never even use. Here's one initiative that we are doing with the help of the community. We are looking at this thing where we move some of the view managers from outside of the React Native core into a core into the core community. The advantage of doing this would be that it'll help us make React Native much more slimmer. This will also help with things like upgrading React Native, because if you look at the last 2 years of React Native version changes, most breaking changes have happened in components, in view managers, and in native modules. Now, if they are outside the React Native core, upgrading React Native should be easy, as long as you don't depend on those core cases. This will also help us going forward when we want to do things like support multiple platforms. If you notice, I've mostly been talking about iOS and Android because they are in the React Native core. But React Native also supports a whole bunch of other platforms, including Windows, including VR, and including React Native Web. Now, if we want a world where we are able to reuse a lot more of our code, like a view on a web versus a view on a mobile device shouldn't be that different. If we want to get to that world, a scenario like this where React Native itself is super slim is going to be pretty useful. In fact, recently we moved one component out and wanted to see how it worked out. So we moved WebView out of the React Native core into the community. And surprisingly, the number of pull requests and issues that were closed in the last 2 weeks was actually higher than the number of pull requests and issues that we closed in the WebView when it was inside the main repo in the last 2 years. So the community has been helping us a lot. And I think React Native can only scale with the help of the community. The other interesting thing that's happening is you shouldn't be just able to replace view managers and native modules. Microsoft is working at this amazing project where they are trying to see if they can replace the core JavaScript virtual machine, JSC, with V8 on Android. This will bring in all sorts of interesting things like performance improvements, V8 snapshots, things like that. So the goal here is to ensure that React Native moves forward, not just because of Facebook, but because of the community as a whole. Why are we doing all this? What's the point of React Native? Well, React Native is actually used a lot inside Facebook. Many of our apps actually use React Native and are fully React Native apps. For example, the Analytics app, or the Ads Manager app, or the Oculus Companion app. In fact, there are parts of Instagram that also use React Native. And of course, the main Facebook app uses React Native in one of its core tabs. The Marketplace tab, which is approximately 800 million monthly active users, is written completely in React Native. And when you open the app, you wouldn't notice a difference whether it's React Native or not. It's not just Facebook who's using React Native. Even outside Facebook, Microsoft is using React Native. You know, Office, Outlook, the Office apps like Outlook, PowerPoint, Word, they actually ship with features that have React Native. Skype has written an excellent blog post about how React Native is helping them move faster. And the Skype team has also done like a ton of contributions. There are many more apps. I actually asked on Twitter for the apps that are using React Native, and here are some of the really interesting ones. The folks at Pinterest, they've done some pretty amazing stuff using React Native. Their entire onboarding screen is in React Native. The Bloomberg Business app, that was completely rewritten in React Native with just 7 developers and 5 months. And at this point, it's like 1 million app downloads. My favorite is the Zynga app. So the Zynga app, the Zynga Words with Friends 2 app, that's actually being converted to React Native. Now, this is a pretty interesting use case because the developers of this app were originally using Coco Studio. And given that they are game developers at heart, they were able to bring in all of those animations, all of those user experiences that they did using Coco Studio into a React Native application. There are many more of these, and I couldn't mention all of them, but this is actually a pretty good number. Overall, I'm super pumped about the prospects of React Native. There are a bunch of new things that are happening, and we want to ensure that we move forward with the community. Thank you, everyone. My name is Parashuram. And we also have the React Native team sitting somewhere around in the crowd, and we'd love to talk to you if you are considering using a React Native app. Here are the Twitter handles of some of the folks of the React Native team. While we don't tweet as much, if you do ask us a question, we would definitely try to answer them. Thank you.